Hello, everyone. Today is Wednesday, 25th of September, and this is a Cluster API officer meeting. Just a quick note before starting. This meeting applies to CNCF code on content. Please be kind with each other. We have a meeting note agenda. If you have topics, please feel free to add them in the agenda, and there is a space for today. Also, please add yourself to the attending list. And if you cannot add to the document, you have to join the SIG cluster Lifecycle mailing list. And if you want to speak, please use the raise hand feature. I will do my best to follow everyone. Okay, we can start with today's agenda. And so, first of all, we welcome new attendees. If there are new attendees, feel free to raise your hand and speak up for yourself. Introduce yourself. Okay, we don't have new attendees, so next point in agenda is...
I'm still looking for the raise hand feature. Sorry, the last time I used Zoom is some time ago and the whole interface changed. Sorry.
Please speak up. Hi, Tilo.
Hi, I'm Tilo. I'm with Flatcar Container Linux. I work for Microsoft. I'm here to chat about in-place Kubernetes updates. I've been in this meeting a few years ago, quite regularly, when we started adding support for Cluster API to Flatcar and vice versa. Yeah, nice to be back.
Welcome back. Nice to see you. Okay, so next topic in agenda is open proposal. We have only one. I don't know if Guillermo want to give an update, if he's in the meeting. I don't see Guillermo. Okay, I can give a short. I know that some discussion are ongoing. Guillermo is going to address some of the feedback from folks, especially about giving a little bit more context and some example at the beginning of the proposal in order to make it more readable. And with that, we can move on to first point in agenda, that is from Tilo, which has a demo, which is great things to see. So I guess you want to share.
Yeah, thanks for having me. I prepared like a very brief slide deck, and the demo shouldn't take more than 10-15 minutes. I joined Linux Me with a separate computer. Let's hope sharing there works too.
I
Okay.
made Tilo Linux laptop cost, so probably.
Awesome. I need both for this, for my Windows account and for the Linux account sharing. All right, it worked. It worked. I just had to click it again. I keep learning cool stuff about Zoom today.
I think that I should stop sharing, however.
Let's see.
Okay,
so, all right, you should see the slide deck. Looks good. Yeah, so this originated in the proposal that we briefly touched on in-place updates. And so we have a working proof of concept on the operating system level, which works pretty reliably. And it doesn't have anything on the Kubernetes level yet, and that's why I'm here. So it's complementary to the proposal. Also, I'd like to note that at this point, it's pretty much Flatcar specific. It does use general Linux functionality and Linux components, newer systemd features. So from our point of view, it should be really easily implementable and reproducible on other distros. And in fact, I have a note on that later in the slide deck. All right. So Kubernetes on Flatcar, we don't ship Kubernetes. We ship Docker and Containerd and make sure that works. And there's a million ways to bring Kubernetes on Flatcar, to install it. In the last years, because of our pitch in the direction of SysX, systemd SysX is the preferred one. It simplifies operations for both our users Kubernetes administrators and us as the operating system providers, and it enables the Kubernetes folks to do in-place updates, and that's why I'm here today.
Sorry, Tilo, sorry for interrupt.
Go ahead.
Everyone see Tilo sharing? Because I'm seeing only my. So I'm wondering if what the recording is capturing now. So could you kindly stop sharing?
Fabrizio, I think you're also still sharing, which is why I can switch to both screens on the top of Cluster API.
Okay.
Oh yeah, that's interesting. But I had a problem also last time that when I was hosting that I couldn't see when Mike was doing a demo. So maybe it's both those problems that you have to stop sharing, and maybe even then it doesn't work.
I do in fact see that.
Okay, could you try to share now?
Absolutely, yes. Of course. Technology, right?
Yep.
Don't worry, this will work out. All right. Should be back up again. Everybody seeing the what's the SysX slide? Awesome. Fabrizio, you're in the game. Amazing. You're seeing my slide. Great. Okay, so I briefly mentioned that in the proposal, and then discussion quickly moved into the direction of what is a SysX and what brings what's the benefit of shipping Kubernetes and a SysX than in traditional ways. So what is a SysX? It's basically a file system image that contains only the bits that you want to ship. In our case, it just contains the Kubernetes bits, which is very easy to do because Kubernetes is statically compiled, and you don't have any dependencies on runtime libs or the like. And then systemd SysX actually takes the job. It takes that file system engine, merges it into your rootfs. So at the end of the day, the rootfs looks like all of the binaries, both from the SysX as well as from your original rootfs, always have been there. Imagine it a little bit like containers, but without any of the isolation. It's just the file system. And it enables immutable, it enables shipping of immutable system features or system extensions. And that's what we use it for. It's been around for a while, for 3 years now. And it recently received a major feature, which is mutability, which opens it up for a lot more general purpose usage. And I have more on that later in this presentation. It also comes with an update story, and that's the interesting part for the Kubernetes world. This update story is independent from the operating system. It's very easy to operate. All right, so how do we provision Kubernetes on Flatcar nowadays? You basically pick a stock cloud image, which you publish on a number of clouds, and then in the configuration for that generic Flatcar cloud image, you just say, I want this and that SysX pulled from this and that HTTPS source. The provisioning process will do that. It'll slap it on your root file system. As you've seen, it'll just make the Kubernetes binaries and the necessary configuration files appear in the final instance, and that's how this works. Very, very brief summary. It really simplifies the maintenance work because it lets us, the OS folks, take care of the operating system. You don't need to build and host your own images. Sorry, it decouples Kubernetes from the operating system, so you can take care of Kubernetes versions and Kubernetes updates, and we can take care of making the operating system, keeping the operating system up to date. And it decouples the cluster API installation from the cloud provider. In fact, you could use the same the same user config here for different clouds. You would end up with the same Kubernetes image. And this simplifies things in a lot of dimensions for us because it really, really reduces maintenance overhead. So that's kind of the benefit that we see in SysX in general. And it doesn't even touch the update story yet. But so this is why we prefer SysX as the way to ship Kubernetes, and why we continue to add it to all of the cluster API providers that we support. But the reason I'm here today is because SysX also have a complementary service called systemd sysupdate, and that is an independent update story that you can basically host and fuel all by yourself, and it's very easy to operate. I will now start sharing from my Linux host and do a little demo of what that update entails, just to show you how just straightforward it is. Please keep your fingers crossed. Share a window. That's interesting. I don't see the...
I made also your second account cost now.
Awesome. I don't see the window I want to share in the list of windows. Ah, that's bad. Okay, let me see. Oh, wait, I have it. I have it. It's here. Just the icon was confusing. Okay, and sharing. You should see a beautiful console. Oh yeah, it works. Okay, so this is a single node thing. We don't even talk full-blown Kubernetes yet. I'm on my host system here. You see the directory. I have a Flatcar image here, which I will boot in QEMU. I have a wrapper script here that makes things easier for me. I have a Flatcar configuration here. That is basically the boot configuration that we use to instrument the instance and to customize it to do things. In this very simple configuration, we tell the instance to, at first boot, at provisioning time, to download a Kubernetes sysext and an accompanying sysupdate configuration file. And then we actually disable systemd sysupdate. But we enable the Kubernetes sysext. And the reason sysupdate is disabled is because I want to demo it. Now, I'm going to start this. And I will not pass the configuration in. So this is basically a boot of Flatcar that has no configuration. The reason I'm booting without any configuration is I want to show you that in default mode, there's no kubelet. Sorry, USR bin KU, there's nothing. If I show you the list of active sysext, you actually see that we ship containerd and Docker as sysext in Flatcar, but that's nothing to do with what I want to show. You basically see that there's no Kubernetes sysext merged here. Now, I will just transpile the YAML file that we just saw to JSON, and in JSON format, I can feed it into the provisioning process. And as far as the instance is concerned, this is the first boot because I ran the thing with snapshot, and snapshot says QEMU after the VM has shut down to not write anything to the actual disk image. So every time I power this off and then start it again, for the instance, it's basically the first boot it ever did. All right. We see now it takes a little bit longer because the instance is now pulling the sysext at boot time, and it's merging it into the root file system. And if you look now, there are Kubernetes binaries here. I can ask kubelet about its version, and Kubernetes is now listed as a sysext. It is actually right here in the file system. We put it here in opt extensions Kubernetes. Systemd is not aware of this directory. Systemd looks here. In etc extensions. And you see there's a Kubernetes raw here as well. And if you check more closely, then you'll see that it's just a symlink, and that symlink points to the versioned sysext that we have here. Now, if you look into the conf file that we've provisioned as well, then you see this is a pretty simple systemd sysupdate conf file. Go here, check in our sysext bakery for anything matching this pattern. So sysupdate is symware aware, and then if you find anything newer than the thing that is here, download it and change the symlink. Now, this is the reason why I have why I didn't start system sys update, so I can demo it, right? Sorry, system start system sys update. Now it takes a little while, and usually that would be done by a timer. So there would be a system timer unit that periodically runs system sys update in the cadence that you wanted to check for updates. And if it finds an update, it'll just download it and stage it. Now you can actually see that this has, sorry. You can actually see that this has already happened. So it checked the index file here, SHA-SUMS file. It determined that there's a new update present, and then it downloaded that new update. And it recreated the symlink to the new opt extensions. If you look here now, we see version 4 has been downloaded. And if you look into etc extensions, we see that version 4 is now symlinked. And what do you think Kubelet will be telling me? Correct, it's still on the old version because the new version only has been staged. Now, to actually apply this update, we could system sysx refresh the whole thing. That would reapply this, or we just reboot to make sure all the pods are down and all the containers are stopped. So now I check the version. I'm on the new version, and I have in place updated my Kubernetes. I will continue the presentation. Back on Windows, share. Here we go. All right, that was a single node demo. That wasn't real Kubernetes. That was just to give you an idea of what sysupdate does. Okay, so publishing and consuming sysx, you've already seen that a sysx is basically a file system image. You put stuff into a subdirectory, you run mkosi or make squashfs or whatever image format you want to use, and you have your sysx. So it's that simple to create. Then you put it on a HTTPS endpoint, and you put a SHA-SUMS file at the same endpoint, and this SHA-SUMS file controls which file system sysupdate actually sees. It'll just check this file. It'll pattern match what we configured in the sysupdate here, and then it'll download and stage whatever image has been updated. We do this hosting, like the stuff that you've seen now, the Kubernetes that you've seen in action right now. This is coming from GitHub. We have a repository that is literally just a bunch of shell scripts that download the recent versions of Kubernetes and a bunch of other stuff that we're offering as sysx. And it has one release, and as always latest. And that's where we basically just show off all the file system images too. And this way we can basically via GitHub Actions have some periodic refresh of the sysx that we're offering. We can also freeze versions. So if I want to demo a specific version, or if a user or customer relies on a specific Kubernetes version present there, we can freeze it so it's always being present across releases. And that's how we do this. And it's that simple to actually host your own sysx images. But now, the reason why I'm actually here, we're gonna do an in-place update of a Kubernetes cluster, of a cluster API Kubernetes cluster. I'm gonna go again to my Linux laptop and share again. And here we are. Whoop. Okay, so the little cluster API cluster that I've prepared here is a OpenStack cluster API cluster. Just because we love OpenStack, it's very easy to handle. We run our own little instance for CI purposes, and you see I have my kind control cluster working locally here. I can check the worker nodes. So this is basically just a wrapper, right? Around kubectl, so that's this. And so those worker nodes have a not quite recent Kubernetes version installed on the bakery. We have 134 already present. And 1 second, I need to. That was fun. Okay, no. All right. So let me get an IP address of one of the nodes, and then I can take a look into that node, and then, oh, that's unexpected. Oh, wait, yeah, okay. I am still in the virtual in the Flatcar machine. Sorry, I did not power down my Flatcar machine, and logically that doesn't have my keys, but this one has. Okay. Brief shock. So if you take a look at this machine, the degree of automation that I have on this machine is way higher than what I show you, what I showed you in the demo. So systemd sys update is already active, has already downloaded new version, and has already updated the symlink. Since we didn't activate this staged update yet, kubelet is still on 133. All of this was part of the original provisioning process. So I can do that in the cluster YAML before applying the cluster YAML to the management cluster. I don't have to fudge anything on the live instances. Like, this can be entirely fully automated. The other thing that we can automate is actually activating the update. Now, the thing that I've taught systemd sys update to do is to create a file in run that will tell our reboot orchestrator, we'll use QD in a second, to just check for this file. If this file is present, QD knows this node will need a refresh. And it will controlledly uncordon the node. It will controlledly evacuate the node, reboot it, and uncordon it. So let's look at the nodes again. We're on all nodes on 133, and now I apply. Oops. My QD service, QD will create a daemon set. It's right here. Oops, whoops, sorry. Pods, of course. It's right here. So that's QD on all of my 3 nodes. And it'll detect that on all 3 nodes, this reboot required flag exists. It will now, it takes usually 30 seconds to start, because I decrease the timeouts drastically just to make it work for the demo. So it'll pick up the reboot required file. It will start evacuating nodes, basically disabling scheduling, making sure all pods are gone from the node, and then it'll reboot the node. Oh, here we are. The first node started. So that's worker node number 1. It's random, but you can, of course, instrument QD to execute advanced patterns and make sure that your cluster workloads always keep running. And now, since this is just a virtual machine, the reboot is really, really fast. And we see now that the first worker node is on a new version. And I don't want to bore you with basically all of the things. I'll switch back, and at the end of the demo, at the end of the presentation, we'll take a look again, and you'll see that all of the worker nodes will have automatically updated to the new Kubernetes version. Okay, that was my in-place update demo. And all of this can be automated. Like, none of this needs to be interactive, right? I'm just doing that here so people understand the individual steps involved. To sum things up, This, on the operating system level, gives you a generic way to update Kubernetes. It puts the control of and the ownership of operating system security and operating system updates back to the operating system forks where they belong, so you don't need to build and host your own OS images and make sure they're updated. You can just use stock distro images and put your Kubernetes on top. You can focus on actually keeping your Kubernetes SysX, up to date and safe. And leave the OS stuff to the S folks. It works on generic distros with the very latest systemd that was released in May of this year. It works on image-based distros, on immutable distros like Flatcar. It works out of the box and has worked for the last 3 years. On generic distros, because these require a little more effort to support, it works with systemd 256, so that should be the next Ubuntu, the next Fedora, all of those. And the reason why you need a newer systemd version is currently, if you apply a SysX, the whole top-level directory hierarchy, you're applying it to, in our case, USR. The whole hierarchy becomes read-only. Now, general-purpose operating systems do not take that well. So what we did from the Flatcar team, because we really like this technology and we really think for use cases like cluster API is really empowering, we added a feature to upstream systemd, which got merged in February and was part of the release in May, that actually enabled a optional mutability. So you can now do systemd SysX merge -- mutable, and then it'll retain mutability of the base directory. It's easy because the underlying technology is overlayFS, so it's actually just adding a few more things to the mount call. We contributed that. We have some use cases for that, for etc in particular, which is also covered by systemd SysX, not for the Kubernetes use case because that always worked. And this enables generic distros to use the very same feature. And then just because that came up, I think today or yesterday in the proposal, what about, all those very, very limited and minimal distros like Alpine or Talos that don't even ship systemd? Now, what the SysX and the systemd sysupdate stuff that we use is actually, there's a specification of that. So I don't know if links work if I click here. Oh, it does. So this is basically a group of image-based Linux folks that Flatcar is founding member of, but lots of folks are in there, Ubuntu, Fedora, GNOME OS folks are in there. And so this is basically SysX. Its extension images follows the DDI spec. And at the end of the day, it is just a read-only file system that is being loop mounted, overlay mounted someplace. And that's how this is. So it's very, very easy to port. You don't need systemd to do a loop mount or to do a overlayFS mount. It has very lightweight metadata. It's literally a few lines that you need to take care, and it's very easy to port. As we keep naming it, it's not more than a glorified overlayFS mount. And this almost concludes my talk. The thing I promised to show you at the end of the talk is, so we have now fully updated, and so the control plane node was last apparently, and it's just about to come back from its update. I'm not going to wait that long because I want to conclude the presentation and the demos. Yeah, I have a final slide, which is more of a brainstorming slide. If you look at this slide, please keep in mind I am an operating system person. I'm actually here to have you kind of, think about this issue, this problem or this challenge. I have no idea about the Kubernetes layer. I love Kubernetes, and I love making operating systems for it, but this is in your court, right? So if you think about how the update mechanism of sysupdate works, all you need is an HTTPS endpoint, and you can specify which endpoint that is in the sysupdate conf. which you pass along to the worker node clusters when you create the worker nodes, right? So in my head, and as I said, I'm an OS guy. You tell me like way better solutions for that. In my head, the management cluster maintains a number of HTTPS endpoints that just offer SysEx, right? With the respective Kubernetes versions you want in those clusters. And this way you can control updates. So the worker cluster will check a specific URL you've specified in your sysupdate.conf, and only after you publish a Kubernetes SysEx there, it will start its dance and it'll do the update stuff. And you will still need to interact with the cluster by means of QD or something else in order to apply the updates and refresh the updates. And that is what I have for you folks today.
And that's really, really interesting. A lot of food for thinking and food for thinking and great ideas. So I don't know. I see that there are some questions in chat. I don't know if I see Christian having chat question, Lubomir having question. Do you want to?
Oh yeah. So the first question is, where's the file system getting fetched from normally? You determine that. In the Flatcar deployments, we just use the bakery. Like we have the OpenStack provider supported with this. They actually use it, I think, in production now. And it uses bakery releases, so we make sure that whatever the OpenStack code currently uses is pinned in our bakery, but it's any HTTPS endpoint. I love to use GitHub for that, just because I can wire up a GitHub action for it, right? And then just do new releases periodically. But it's entirely up to you. Fetched via HTTPS. Can in-place upgrade in an air-gapped node container images? Yes. I mean, as I said, you only need an HTTPS endpoint, and you probably have some kind of centralized server in an air-gapped environment just to control your air-gapped environment. So you just put it there alongside with all of the other stuff that is there. So providing this doesn't really need a fat server application. It's really, really lightweight.
Cool.
Okay.
Thank you.
There's one more thing I need to mention. I forgot to mention that in a brainstorming slide. Right now, my management cluster, like my kind cluster on my machine, still believes that all of the worker nodes run with like the old Kubernetes version that they were deployed with, right? Because I'm not a Kubernetes person. I don't know how to tell them that. But maybe I got your interest, and yeah.
Yeah, this is definitely interesting. I don't know if someone wants to comment. I'm sorry there is no Guglielmo in the meeting, but yeah, I can give you. So to the last point, cluster API, let me say, that doesn't have a notion on what happened on the machine. It's assumed the machine are immutable. So Guglielmo proposal is try to add at cluster API extensibility point. So basically, you can do in place mutation like the one you did, but not only. For instance, you can do other type of in place mutation. For instance, change the machine itself, add memory, expand the disk, act at the infrastructure level, and I see, let me say, as two sort of complementary work. Guglielmo is trying to find a way that you basically in cluster API, you initiate the upgrade, and then at a certain point it call out to something that is responsible to change in place the machine. And this is where a solution like the one that you just explored can really play well, much better than a script that download stuff and do all the magic. So I think that we are trying to solve a very complex problem. I just want to remind a point that is also in the Guglielmo proposal, that you know, that there was a lot of discussion in cluster PI between mutability, which one is better, which one is worse. So I think that the point here is sort of, you know, we learned that immutability has a set of advantages. You know, it makes things easy for when you troubleshooting. It make it easier for it to solve a set of problems. But in some case, mutability, yeah, it is a little bit too much cloud native for users. It's like immutable OS system. So folks don't always get it. And so Guillermo proposal is taking this, and the goal is, okay, if some user want to trade in some benefit of immutability because they need it, or they like in-place mutation, or whatever, for every reason, we should make it possible. And this is the idea behind it. And I really like seeing the different projects coming together. And thank you very much, you again, for doing the demo. Are there other comments? Someone that want to comment on top of this? Otherwise, I go back to the agenda. Let me share again. Great, thank you again, Thilo. And next up is Mike.
Yeah, this is should be pretty quick, but we've been expecting this for a while now. The repository has been moved to Kubernetes SIGs. I'm planning to add some more issues over the next probably week or two to help just broadcast more work we'd like to do. And I think now we're going to focus on experimentation and kind of working towards putting together an enhancement proposal that might capture, you know, how we want to do Carpenter integration. But I think, you know, there's lots of kind of fun experimentation to happen at this point. And so I don't think we're going to rush to make a cap for this, but maybe over the next 2 or 3 months, we'll start working towards it as we try out kind of different topologies and whatnot. So anyways, just wanted to announce the good news here. Looking forward to contributions from anyone who would like to kind of play with this stuff. So thanks.
Thank you to you for taking care of all the, you know, moving the repository dance, and yeah, and also thank for the contribex folks that helped for the final step. Next up, Stefan.
Okay, probably should start with a bit of context. So we did a few improvements in the last few weeks or months to basically make node train better and also make node train observability better. What it came down to is basically we were using the kubectl train library before. And it had a few downsides, like it was spawning like one go routine for every single pod that we were evicting and then actively waiting for 20 seconds in the middle of the machine controller reconcile and stuff like that. So we improved that stuff. We made it easier to observe in the sense of that we're writing better logs and better condition while after that's happening. One change that we also made in there was that we are now actually ensuring that all the pods that should be drained are actually drained from a node before we are moving on with machine deletion. That wasn't the case before, because before you were evicting pods and then we were waiting for 20 seconds. And if you got lucky, within 20 seconds, all the pods were like terminated and immediately gone. And then we were just moving on. But now basically we are requeuing instead. And requeuing instead basically means that there is no more like, oh, maybe we get lucky in 20 seconds and we're just done. It's more like, okay, we see on next reconcile, are there still pods around? And what can happen essentially, if we have some pods that are tolerating all taints, they might just immediately get evicted, but they're also coming back. And they're, because the kube schedule would just reschedule them, because if you tolerate the no schedule taint, the kube scheduler doesn't really care about your training node. It even has a slight tendency to prefer your node because it's nicely empty. So why not just put more pods on it, right? So TLDR, we made some improvements. The result, unfortunately, is that there are edge cases where people are tolerating all taints, where the chances are now higher that machine deletions are getting stuck. So that was like one reason why we're looking further into improving node drain. This issue here is another reason. So basically, that issue was about, I would say the headline is making sure that pods are drained in the right order, because some people have requirements that basically, let's say first their application pods have to go, and then something like Podworks, which provides, as far as I got it correctly, a corresponding storage. That's also something that is not possible today because, yeah, there is no order. We just drain everything at the same time and then keep on draining until everything is gone. So that was always the case. So what we're doing now is we're basically working on a small proposal to extend Cluster API to allow people to configure how the drain actually works. And that is mostly about two topics. Let's say two major things that you want to make happen there. One is that it's possible to specify ordering, like which pods should be drained in which groups and after another. And the other one is to make it possible to actually skip draining pods. So that would be for pods that either should never be drained or for pods that have just toleration so that you can't actually drain them because they will just always come back. So that's a rough direction. I'm planning to open a proposal PR early next week is the current idea. So this is mostly a heads up to give some context, and heads up for like reviews would be great. And basically the thing is, compared to the last Cluster API version, Drain now behaves differently. So we're really looking for to adding like an additional feature to make sure that this difference that we now have doesn't lead to problems in the next release. Yeah, I think I covered most of the points, Fabrizio. Did I forget something important?
No, I think that this is a great contest. Overall, this you know, we always had in the past a lot of feedback from users about our node drain process. That in a combination between doing drain into reconciling and all the edge case that you can find out in the wild. Let me say it was not flexible enough, and I thank you very much for all this work that I think we'll give another edge to Cluster API, because we will be even more flexible and configurable than kubectl drain. Lubomir.
Sorry, I kind of phased out because I was looking at something else at the beginning, but did you mention the existing Kubernetes proposal to have declarative node maintenance? I have
I searched for the answer.
you mentioned it.
Sorry, you go first.
No, I'm asking if you mentioned it. I didn't see it. It was on LinkedIn ticket.
Yeah, I didn't mention it, but we are aware of it. I spent like half a day or a day, like yesterday and today, to look at through this entire proposal and give a lot of feedback there. Yeah. I mean, what we're basically trying to do is, I think, two things. One thing, try to give feedback on the proposal to see that we get closer to like a standard solution within Kubernetes. But I also think, based on the current state of the proposal and the current discussions on that proposal, I don't know when and if that will happen. It sounds for me, it sounds like there are really like, there's like major difference in opinion there between, should this even go into core Kubernetes at this point? Should they build like this entire thing first, like as an external project with CRDs, and then eventually somehow it maybe makes it into core Kubernetes? And there are like a few big questions open like that. I'm not sure if we can basically wait a few years until this makes it, or if instead, or maybe not at all, or if instead we're looking for something which solves our current use cases. We do it in a way that it's not like, you know, we won immediately and we can never get rid of it, but basically get it out as an V1 alpha or something, see how it goes, see how the upstream proposal goes, and then see if we can eventually realign, or if the upstream proposal never makes it, essentially only have our option. What is also very clear in that proposal is that a lot of other projects already build a lot of other solutions, and I mean, compared to what cluster autoscaler is doing, for example, what we have in cluster API is really basic. So I'm not sure if we basically should just wait in Kapi until maybe in a few years something in core Kubernetes comes along. But what I 100% think is that we should try to contribute to get or at least give feedback on a proposal to make our voice heard there and get our opinion.
I completely agree. I feel like this upstream proposal is trying to do too many things in the same cap. And I also think that it should be potentially external. They, how do I say, they jump in a pretty big hoop trying to land in core right off the bat, and other APIs have been proposed to start external and then potentially go internal. So I think it's a good idea to probably get something going in Capi, but I don't know if you have already some draft design in mind, but how this should be swappable potentially in the future should be key. So, minimal breakage to users potentially. Like, how do you swap this with a eventual centralized Kubernetes feature that everybody wants to use? Might be not so easy, but it's a similar story with the reference grant. How do you make it swappable in the future potentially? So it could require some brainstorming, I think, but I'm generally +1 to get this going. I'm just giving a vote here, and I wanted to see if you have considered upstream stuff.
Yeah, yes, that's good. We definitely have some concrete ideas. It's just let's wait until early next week until we push that one out. But we looked at what we want to do. We looked at what the node maintenance thing is doing. There is some overlap, but it's also some. So, for example, the skipping node drain for some pods is not a topic there. They're saying we want to always evict all pods, including daemon sets. And I'm not sure if that's the right thing to do, but I also don't know where. I mean, basically, we're talking about a work in progress cap upstream, so we can't also really try to align what we want to build in cluster API to the intermediate state of a in review cap and try to match their target state. So eventually we can easily migrate. It's like an entire moving target from start to finish. So yeah, we have to think how we want to do it and how also to expose it and all of this stuff. It's just hard to try to align to something which is absolutely in progress and under discussion.
Yeah, I'm not saying that. Basically, if you look at the upstream proposal, you can say, hey, they have good ideas, but I think Capi can pretty much bake its own idea, to be honest, because that upstream cap I think is doing proposing too many things. It's a bit too opportunistic in a way. That's my thinking.
Maybe 2 additional comments. One is, I mean, I definitely have some rough idea how essentially what we are going to propose could build on top of something like node maintenance API. Because, I mean, we're always talking usually about configuring something in the management cluster, while the node maintenance API is building something in every workload cluster, essentially, right? So there's always, I guess, a gap to bridge between what you configure on our side and what ends up in every single workload cluster. And also just to mention to a wider audience here, they're not only trying to add a node maintenance API, they're also trying to build another layer of API around the eviction API, which they call the evacuation API, which is also, in my opinion, like a major undertaking. So I think if it happens, it will take a lot of time.
Beans?
Yeah, no, I think this is fantastic. So we have had our own set of issues with drain too. I would say so I did understand one thing you said, you want to drain daemon set as well all the time, or is that something that we don't want to do? Because I wouldn't want to do that.
Yeah. So the upstream node maintenance cap in its current state is basically saying the goal of node maintenance is to drain every single pod on a node. And that includes daemon set pods, and that even includes static pods. So I'm not even sure how this is going to work for control plane machines, but I'm also not sure yet if they're really planning to evict like API server, etcd scheduler in the right order, while kubelet somehow still works, but kubelet has to use that API server that they're killing. But I asked a bunch of questions just today, so maybe it all makes sense. But it seems very tricky to do. No, what I tested and what I realized is evicting daemon set pods today doesn't make sense, because the daemon set controller will just recreate a pod, and it will put stuff like unreachable taints on it, so that pod will actually come back. So if you try to evict daemon set pods, they will just be always being recreated. So that's why in what we're currently thinking about would not touch the daemon set thing. We would just say, okay, we're never going to skip daemon set pods, just the same as today.
Okay. Yeah, I agree with that approach, especially because like you can run things like connectivity with the K to talk to the API server. Then if you drain that goes away. Cool.
Okay.
How do you even drain a static pod? I'm confused. Like
So they're planning really a bit like widespread changes, right? I mean, one thing for daemon set use case, they want to add also feature gate to the controller manager, which is like node maintenance aware daemon set controller or something. And then they're saying, okay, on one side a daemon set controller, I get to kubelet in a second. On one side a daemon set controller is going to take over getting rid of daemon set pods, but on the other side is also not going to recreate pods while the node maintenance is going on. And for the kubelet thing, I don't know how exactly it will work. I'm also not like, let's say, a super expert on on the graceful node terminate feature that apparently only works on Linux. So it was a bit complicated for me to understand. But overall, I think they basically wanna make some changes in kubelet to make this somehow work. I think there were no real details around how exactly it would work in kubelet. And there was also a statement somewhere that this would require additional caps for the controller manager, but definitely for the kubelet.
Yeah, it feels like there's like almost 3 caps in the same cap right now. There's so many comments on it. Anyway, I think I'm plus one to cap it to implement its own thing and make it potentially swappable.
I mean, I definitely don't need like, very early opinions. I mean, I try to get it out next week. Totally fine to, take a look, see what we need, see if it makes sense, and then go from there in the discussion. I mostly want to give a heads up, but definitely a great discussion so far already.
Yeah, this proves that it is an important topic to address, and thank you, Stefan, for digging into it. I invite everyone to take a look also the upstream caps. Okay, before moving to the next topic, just a great call out from Thilo is that Flatcar now is a CNCF project, and congratulations for this. We were waiting for this. So yeah, use it. It's part of the ecosystem. Last point in agenda, it is from me. So last week I told you that I'm going to start doing some refactoring on the book, mostly to surface the work on condition. This work is currently only on main, on the main version of the book. You can easily access it by just putting main dot in front of you. What I'm doing is working on developer guide. I'm splitting up what is important for developing core cluster PI and what is important for developing provider, trying to have a clean separation. Next part that I'm doing is that I'm reviewing provider contracts. I started from the infra cluster, and now what you get is in a single page, you have all the rules that apply to infra cluster. You have also a nice table that allows you to get an overall picture. And so everything is linked from here, also cluster cut or multi-tenancy. So I'm making sure that the documentation that before was spread in the book, now it is in a single place. And the last bit of work that I'm doing is also to give heads up. So in the same page, when there is something that is going to change in the next API contract, because it was defined in the proposal for improving status, I'm already starting to call this out. So yeah, it is a huge work. It would be great if someone working on provider could take a look and give a feedback if this makes sense or not, and looking forward for those feedbacks. Thanks you, Mike, for the feedback. And thanks, Christian, as well. So, Stefan? just
I think you already sort of hinted
just,
at it, but just
we are
because
3 minutes before the end of the meeting. So
I'll be
please.
very quick. Yeah, thanks. I think Fabrizio already hinted at it. Feedback would be great, but also let's just try to keep improving and evolving this going forward, because I think the problem we had in the past is that our contract was all over the place and a bit messy, and it was very hard for new people or probably everyone to just get like a good picture of what the actual contract is for like an infra provider or something. And I think, I mean, that's a very good first step to get everything into one place, and then we have to just make sure that it stays up to date going forward to make it easy for everyone.
Thank you. I see a very last second topic to be being added to the agenda, Christian.
Yep, I just want to announce that we had or did patch releases for Cappy yesterday, because we reference CSI manifests in our templates, and the registry for these images got moved. So feel free to update to the new patch releases and use the working templates.
Great call out. So we are at time. Thank you everyone for the great discussion today, and see you next week. Bye.
Bye-bye. Thanks, Fabrizio.